Okay, and we are live. Hi everyone, good morning to our lecturer, Dr. Siti Mariam Nora Shekin, and my fellow teammates and fellow board of directors. So, welcome to the Lajak Kuruih top management meeting. Today is the 2nd of July 2020. Today's presentation will be brought to you by my team, which is the Pure Lajak Kuruih K. So without further ado, we will introduce ourselves, starting with me. My name is Chan Wailun, and I'll be the moderator for today's meeting.
Hello everyone, my name is Muhammad Wafiuddin bin Muhammad Saleh and I will be explaining about summarize of data.
Assalamualaikum warahmatullahi wabarakatuh. My name is Faris Raimi bin Yusli. I will presenting for part B.
Hi, my name is Shazafi bin Shazli and I will explain about the part C, which is we're using the Anova analysis.
Assalamualaikum and hi everyone. My name is Muhammad Rakim bin Omar and I will explain about part D.
Before we begin the meeting, there are some keynotes that we will be talking about, we'll be discussing in this meeting today. The first is summarized data. So we'll summarize all the data that we've collected and we will explain it to you. And then the next one is goodness of fit analysis and Anova analysis, and then linear regression analysis. So let us begin.
Okay, the first thing of summarized data is the summation of weight of tablet K, which is we have divided it according to the shift of the tablet that was produced, which is morning, evening and night shift. If you can see in the slide, evening shift have the lowest summation of weight, which is 21,465.94 milligrams, and in the morning shift, the tablet produced is 23,730.64 milligram, and in the night shift, 24,480.77 milligram, which brings the grand total is 69,667.35 milligram. Moving on to the next point is the relative density of tablet K, which also we have divided it into three classes, which bring the relative density for evening shift is 5,454.9%, and morning shift is 5,949.1%, and the night shift is 6,142.8%. Moving on to the third point is the tensile strength for the production of tablet K, which also the evening shift has the lowest tensile strength, which is 440 megapascal. In the morning shift, the tensile strength is 479.1 megapascal, and the night shift is 495.1 megapascal, which brings the total tensile strength is 1,414.2 megapascal. I think that's all from me.
From the question given, it said that Food and Drug Administration requires the weight of tablets should be normally distributed with 350 mg with standard deviation of 40 mg. The question is whether the data is following their requirements or not. For this problem, I am using goodness of fit test method. First of all, I plotted a frequency graph with 5 class interval so that I can easily differentiate the data. Next, I made two hypothesis statements which I said earlier. The first one is the data is following their requirements, and the second one is the data is not following the requirements. If the chi-squared test is lower than critical value, so I take the first one, and the second one is the other way around. After that, I find the probability for each class interval and multiply them with total number of data. I using a chi-squared test formula to get the result. Next, I have to find the critical value and plotted chi-squared graph. So Our result is chi-squared test is lower than critical value, so which means the weight of tablets is following the requirements. That is my conclusion for this problem.
Okay, so for the Anova table, first we get the SSTRT, which is 439.1291. So this value we get from the summation of yi squared over ni minus y squared over n. And we get the SSE value, which is 34372.51. We get from SST minus SSTRT. So to get the SST value, which is the total, we get from the summation of yig squared minus y squared over n. So moving to the next part is the degrees of freedom, which is the df. So for the df for between groups, which is 2, we get from k minus 1, since our k is 3, so we get 2. And the n minus k is 197, since the n is 200 and k is 3, so we get 197. The total is 199. We get that from n minus 1, which is 200 minus 1. So moving on to the mean square, which is MSTRT, we get that from SSTRT minus k minus 1. So SSTRT, which is the 439.1291, we divided by k minus 1, so we get that 219 from 219.5645. So for the MSE, we get that from SSE minus n minus k, which is the 34372.51 minus by 200 minus 3, divided by 200 minus 3. And to get the F calculated, we get the MSTRT divided by MSE, which is the mean square minus divided by MSE. So we get 1.258396.
Now, I will explain about the solution. First of all, what is the question? The question asks us to find the prediction of the tensile strength for such tablets based on the low relative density values of 68%, 74.3%, and 80.1%. Our group choose the Lajak Kuruih tablet K data for this, and I use estimation method to solve this problem. Now you can look the solution. I use this formula and got the answer, and we use the same calculation for 80.1%, 74.3%, and 68%. So here are the result. We have calculated the tensile strength range for the cluster given and compared the result of our data with the cluster. Based on the data, the values for alpha 68%, 74.13%, 80.1% is 0.12, 0.32, and 0.257. By doing calculation, we can see that the values by using alpha 88% is 7.094 and 7.084 megapascal. Hence, the value for mean for 80.1%, 74.3%, and 68% is between range, which are true and accepted. And due to the relative density is related to tensile strength, we can predict that the mean 7.071 megapascal is the most suitable value for tensile strength for alpha 88%.
Okay, so now back to me. Based on all the analysis from the data that we have collected, everything seems to be running smoothly. There are no problem with any of our production line, and everything, all the product is running smoothly according to the requirement that we want. So with that, I'd like to end this meeting today. Thank you for your time. Thank you for coming. Thank you for participating. Yeah. Goodbye. My name is Chan Wailun from Lajak Kuruih. You might know us from our famous health product, which is the pill Lajak Kuruih K. In Lajak Kuruih, we strive to deliver the best product for our customer. Hence, Lajak Kuruih invested a lot to make sure that every single product that we produce are at the highest quality. With the help of my teammate and I, we made it possible by making sure that each and every single pill that we produce met a specific requirement before we put it on the market. With all that hard work and determination, it is no wonder that our product, the pill Lajak Kuruih K, was nominated and won the most trusted brand by consumers by Reader's Digest. For all our customers, thank you for your continued support, and we'll keep delivering you with the best product.